just to sort of get away from the idea on containerized networks and moving into the concept of containerized applications. One thing that has come around recently, has been pretty popular in large scale services, is to containerize your software, as well as incorporate containerization wherever possible. And these are technologies like Kubernetes and Docker and things of that in that idea. So the thing that is a security advantage here has to do with the idea that when you put a container out there, if they're built correctly, the intention there is that they're immutable. And what that means from an attacker's perspective is that if you are trying to attack a container, unless you have an additional exploit, your attack when you get on to that machine is not only limited in its scope and its ability to do what it does, because most container services limit what a container is allowed to do when an application is put inside one. But it also creates a scenario that if a difference is detected in that container, it is quite often automatically shut down and restarted and put into a state that it was previously. And so when you put these things into your networks, it creates a bit of another layer of security that creates a bit of a fail-safe. Now, these are also pretty good if you are to, they do scale pretty well, but as I think Dan might have some perspectives on here, if they are locked down too much, they might have issues scaling as well. One other thing I wanted to mention before I sort of give the floor open to see if anyone wants to banter back and forth across this idea or wants to ask me or prod me a little bit further, has to do around the idea that the containers themselves, if they are not set, they take a little bit of extra massaging, and it usually requires an engineer's understanding or getting a container from the software provider themselves if they're a third-party vendor. So yeah, I mean, they're just really nice because if there is a vulnerability associated with them, often it severely limits their impact if an attacker is attacking it. And since these things are mostly to service the public side of the network, it does create an additional layer of security.
Yeah, Ryan, you're right. It's a trade-off. You know, we just saw this recently. If you follow any Bitcoin news, Coinbase, one of the biggest exchanges in the world, went offline, and they weren't allowing people to do any trades. And I know from some inside knowledge, I know the people at the security team there, like Philip, a lot of their software is containerized, and it's good for security. It's like you said, it's a trade-off. So they have some of the best security, where all of their things that are in production, things that they deploy are containers. So the security is very tight. But then you see the problem if there's a huge surge in requests from the customer side, they can't scale as fast as if they were to have a little bit less security, but then we're able to scale faster because of that trade-off. But you know, for organizations that need a lot of control over the supply chain, containers are great. You know, then you can control like what the dependencies are. I remember whenever containers first became popular, like Docker, it was very cool to download some program in a container because it had all of the dependencies already built into it.
Yep.
So we can just
absolutely
the image, that Docker just comes as an image. You scan that, like, okay, this is secure in its current packaging, and then go and deploy and run it. So there are things that I like about containers. I would never, tell somebody not to investigate to see if it's right for their environment. But it's always good for us at Blue Team Alpha to be aware if there are containers in the environment, because that is an additional type of vulnerability that we have to check for.
How common are these? Is it hard to build? I mean, do most people just stay away from it because of the challenges, or?
Well, I think that there's been a big push. They do work over content delivery networks pretty well. So in some of the major software companies, as long as they're put together well, they do scale with demand pretty easily. They tend to work, they're most popular on the popular cloud provider platforms like Amazon and Azure and things of that nature. And a large number of third-party vendors provide containers, especially for their popular applications. You know, if you were like trying to do it with databases and things like that, it'd be a lot more difficult just due to the nature of database. But yeah, there's a lot of different ways that you might have to approach it. If you are developing software in your organization, it's definitely something you should look into, I would say, because it allows you to provide a level of security that often comes as a challenge for engineers, or like as an IT provider providing security to engineering laptops, they have a lot of exceptions that have to be made. Typically, you typically have to allow an engineer to have local administrator rights. You often have to allow the engineer the ability to engage with business critical infrastructure that's servicing your you know, your company's, you know, like revenue, just from the application itself. And if you are able to set these up correctly, it allows a chain of custody and an approval process to the code. That means that a low-level developer isn't going to necessarily wreck your server, because it can go through a specific pipeline, go through debugging tests, make sure that it works before it goes into production. And these things can be enforced. And, you know, you have a much, how would you say that? Least privileged use, but
Yes.
more of it.
You made a good point about limiting the impact. That's another cool thing that I like about containers, because if something breaks in a container, it doesn't ruin the entire environment, you know, and it can be redeployed really easy.
By default, they typically redeploy or restart immediately and start yelling at you, you know, from the monitoring interface. So
a lot of
these are very. What's the difference really between, you know, the major difference between like a VM, you know, like virtualization's been around.
Oh, that's a great question.
A long time, right? So
yeah,
when you think of like virtualization and microsegmentation, even in virtualized networks, like what's the major difference there, and what's the major benefit to going containers over a VM?
That's actually a great question. And it really allows me to I'm serious. It really allows me to talk to the side of containers that like one of the first questions that's typically asked, especially by an engineer if they haven't heard of it before, is what's the difference between that and a VM? The way that containers are built in a virtual machine, the container exists, the security container. When we say container, we're referencing an imaginary boundary that prevents that machine from interacting outside that boundary, except for ways that we've put holes in to allow it to receive information, send information out, and vice versa. A virtual machine is an entire computer that has its boundary set at that level. Whereas containerization and containers like Docker and Kubernetes, they are focused on the application itself. So the container is shrunk down inside the computer and exists as a very small application that, as long as the other machines are running the same software, is easy to deploy across, sort of like in a peer-to-peer network kind of way as necessary. But again, these containers also, so, you know, the boundary exists there, but the other aspect here is that what's it called? The features of the operating system that are allowed access by that small program are much more limited. Sure. And they often exist in a way that is actively trying to prevent the containerized software from interacting with the rest of the machine in an unsafe way.
Yeah.
So the basically hardware. Yeah, it's just got a shrunk down footprint. It's not running a full operating system and everything else, right?
That's right.
Like
it's running the minimum amount of components necessary in order to execute the service.
Right, which would then shrink your footprint. I mean, substantially, right? Even I'm, just thinking about, I
Cost.
know it's a topic for later, right? But operating system costs. You have vulnerability management. If you have a bunch of VMs, you've got to do vuln management on every single VM.
Yes.
All of the aspects of
And the OS
that VM. So it exponentially explodes your vulnerability management program too. So so I mean, there's a big benefit there.
They're more expensive also. So for budget.
Yeah.
Right. Well, and a full VM would use a lot more resources, it sounds like, for ancillary things, not having to do with the production of what you actually wanted.
Getting charged CPU costs for, the system idle process that's running some background checker or file cacher. I would caution one area that I would say, just being myself with a background of engineering and software development, I don't want to put too much on my fellow, engineers there on that side of the house. There are some situations where containers are not the best use case, and there are some situations where the process that you're trying to make into a container needs to undergo a bigger transformation. Mostly it has to do with data paths and them being shaped, instead of like a single line, having a Christmas tree parallel processing. And so there is often in the software development process some changes that need to be made if you are building your own custom software there. There's a lot of guides online. Most engineers can get up to date with it. But like I said, it's a super cool idea. It works really well. It is pretty secure, but one size does not fit all. That's definitely true.
When you're going from VM to VM, right, you can encrypt the traffic between them, right? Because they're full OS.
Yes.
So you can encrypt the network traffic from one VM to another VM. Can you do the same thing in a container, from one container to another container? Can you encrypt the traffic, the data?
Yes, you absolutely can. And in fact, that is one of the things that you might consider a con, is that there is the possibility, if the containerization is not deployed correctly or built properly, of creating sort of listening areas or vulnerable areas of the application, because it might be split between multiple containers. That data path in the original program wasn't thinking that it was going over a network. And so this data might be critical data, that might be sensitive data, that if an attacker were able to listen to, might be bad. So there are encryption algorithms that for the message passing services, but you just need to make sure you utilize them.
One last thing about containerized systems is that they're typically stateless. So if you need stateful persistent storage, containers are usually not the best choice. A VM, in that case, with a virtual hard drive, we lean more towards VM in that case, if you need that stateful persistent storage. But if you just need a stateless app, container, cheaper, faster, in some cases more secure.
Absolutely. My challenge would be talk to your engineering department if it's your own software and you're interested in learning more about this, because it's most likely they're familiar with it.